working with the Pythagorean theorem today. Okay, today we're just going to look at the converse of the Pythagorean theorem. Now, converse means that you can read it the same forward and backward. Okay, so if I have 6 plus 5 equals 11, then I could also read that as 11 is equal to 5 plus 6. Okay, so you can read the same equation forward and backwards. So, looking at the converse of the Pythagorean theorem, now we have, if we have a squared plus b squared equals c squared, then you have a right triangle where c is the longest side. So if it happens that you are given 3 side lengths of a triangle, and you put the 2 smaller sides in for A and B, and they happen to equal that c squared value, then you do have a right triangle. So it's just kind of this backward statement of the Pythagorean theorem. So we can use the sides of a triangle to classify it. Okay, so we are going to be classifying triangles today. So our different classifications for a triangle are right triangle. Okay, you have one 90-degree angle in a right triangle. An acute triangle, all of your angles are less than 90 degrees. And then an obtuse triangle, you have one angle that is greater than 90 degrees. Okay, so in a right you have one that's 90 degrees, acute, all of your angles are less than 90, and obtuse, you have one angle that's greater than 90 degrees. So using the Pythagorean theorem to classify our different triangles, the first one is just our Pythagorean theorem. So if we have c squared is equal to a squared plus b squared, it is a right triangle where c is the longest side. Okay, so you can see that here. We have a right triangle, c would be our longest side. In an acute triangle, that c squared value is going to be less than that a squared plus b squared value. Okay, so that side squared will be less than the other 2 squared and added together. Again, where c is the longest side. Okay, and you can see all my angles here are acute. Okay, they're less than 90. The last one for obtuse, your c squared value will be greater than your a squared plus b squared value. And again, c has to be that longest side. Okay, and you can see that here. We have our one angle that's greater than 90 degrees, and c is our longest side. Now this will make more sense when we do some examples. Okay, but any questions before I jump into those examples? All right, so the examples at the bottom then, we want to classify each triangle as acute, right, or obtuse. Okay, so I'm still just going to use the Pythagorean theorem. So the first thing that I do is identify my longest side. Okay, so your largest number is your longest side. So number 1, that would be 16. Okay, so that has to be my c value. Now, I'm going to set this up how I have them laid out up here. So I'm going to write that largest side squared first. Okay, so your c squared value first. Now instead of writing equal to, I want to compare these. Okay, so I'm just going to leave this blank space here because I want to compare that largest side squared to the other 2 sides squared and added together. Okay. So then I have my other 2 sides, a and b. Again, those can be interchangeable. It doesn't matter your order. So I'd have 7 squared plus 14 squared. Okay, so from here I'm going to square each of my numbers. So we have 16 squared, that's 256, compared to 7 squared is 49, plus 14 squared is 196. Okay, then I just want to add these two numbers together. So I still have 256 compared to 245. Okay, so those are not equal. That's why I didn't want to write the equal sign, right? Okay, they're not equal to each other. However, 256 is greater than 245. Now your greater than symbol always opens up to the greatest number, if you forgot. Okay? Opens up to the greater number. So 256 is greater than 245. So I'm going to look back up at my chart here and see where that c squared value is greater than. That's right here. So this must be an obtuse triangle. I'm just going to write a triangle symbol for that. You don't have to write out triangle. Okay, so number 1 was an obtuse triangle. Okay, questions? All right, try number 2 then. For these, you do want to make sure you're showing your work. So at least writing this up, okay? And then you can write this one right away if you want, but you do need to write out this inequality statement here. Okay, so you do want to write out both of those numbers and then compare them with a symbol. Okay, so if you skip where you add them together like this and you just enter 7 squared plus 14 squared in your calculator and it spits out your number, that's fine. But you do need to write out at least both of those steps to show your work. So most people were done or almost done with this problem. So again, my first step is to identify my C value. Okay, that's 41. Because it's the largest number. So I would have here 41 squared, again starting with that largest side, compared to 40 squared plus 9 squared. Again, those are interchangeable. So 41 squared is 1,681, compared to 40 squared is 1,600, plus 9 squared is 81. So we have 1,681 compared to 1,681. Okay, those are equal. Since they are equal, that makes this a right triangle. Okay, that's the easier one to remember. Questions on 2? All right, then we're going to go through it 3. So this time it looks a little bit different. So if you don't know which side is your greater side, you can probably determine just from looking at it right now. But if you aren't positive, what I would do is plug each into your calculator. Okay, so if I plug in the square root of 5, I get about 2.2. Okay, don't write that down. Don't write 2.2 down. You want to keep it in the root symbol. Okay, so I get about 2.2. So I'm going to check the square root of 12 next. Okay, square root of 12 is about 3.5. So that's greater than 2.2, so that's my greater side so far. But I still have to check the square root of 13. And that's about 3.6. So that is going to be my greater side. Okay, so if you don't know which root is larger, plug it into your calculator, find those decimal approximations to decide which one is your C value. So in this case, the square root of 13 is my C value. It is the greater root. Now when I plug these in, I do want to keep them in that square root. And you'll see why in a couple seconds here. So for that first one, I would have the square root of 13 squared compared to the square root of 5 squared plus the square root of 12 squared. Now if I square a square root, they cancel each other out. Okay, that's why I didn't want to write down those decimal approximations. So my root and my square cancel. I'm left with 13. Here again, my root and my square cancel. I'm left with 5. And then same thing for 12. Okay, that's why you want to keep those in the square root, because you're going to end up squaring them using this. So here I have 13 compared to 17. 17 is greater. So my inequality symbol here would be 13 is less than 17. Okay, if it's less than, that makes this an acute triangle. Okay, questions on number 3 with those radicals or square roots? Are you still with me? Yes? Okay. Then number 4 is similar to this, okay? So again, if you don't know which one of these is bigger, you need to plug those into your calculator. Okay, so first one is 2 times the square root of 3. Okay, so that first one is about 3.5. Next, we have 4 times the square root of 4. What is that without your calculator? 8. Okay, so that one's bigger so far. And then we have 3 times the square root of 5. That's about 6.7. So which one is my greater side? 4 square root of 4 is my greater side. Okay, so that'll be my C value. This time, make sure you add the parentheses around. Okay, so we have 4 times the square root of 4 squared compared to 2 times the square root of 3 squared plus 3 times the square root of 5 squared. Now, if I have 2 numbers multiplied together like this and both are squared, I have to distribute that square to both terms. Okay, so I have 4 squared is 16 times the square root of 4 squared is just 4. Okay, because your root and your square cancel. Okay, then that's compared to, again, distribute your square to both numbers. So we have 2 squared is 4. And then the square root of 3 squared, your root and your square cancel to get 3. Plus 3 squared is 9. And the square root of 5 squared is 5. Okay, so next I can multiply together here. So 16 times 4 is 64. That's compared to 4 times 3 is 12. Plus 9 times 5 is 45. So we have 64 compared to 57. Okay, 64 is greater than 57. Okay, since it is greater than, that would be an obtuse triangle. Questions on that last one? You good? All right. Then on the back, I'm going to have you guys do 5 and 6. So number 5, this one is already a right triangle. It's already a right triangle. You're not determining if it is a right triangle. You're just using the Pythagorean theorem to find that last side. Okay, a squared plus b squared equals c squared. Okay, so you're doing 5. So that's from yesterday. 6 is from today. You don't know if this is a right triangle. You have to determine if it is a right triangle. So use what we did on the front to answer number 6. Okay, so do 5 and 6 in your groups. Number 5 can't be simplified if that's what you're trying to do for 10 minutes. Just so you're aware. Just making sure you do that. So, I tried so.
That's what I spent the last 2 minutes doing. I think you should just have that as a note over here. Like which ones can't. I spent the last 15
I don't
minutes
think
doing
I don't think I'll give you a big number like this on your quiz. Or if I do in the directions, I'll say round to the nearest tenth or something like that. And then you can write the decimal. All right, I want to get started going over 5 and 6. That way we can get to number 7 and then you can do your assignment. So in number 5, again, The triangle is already a right triangle, so we can say that this is equal to that hypotenuse squared. On quizzes and tests, you need to at least write this out so I know where your thinking was. Okay, so don't do everything on your calculator and just give me a number. At least write this out so I know what you were trying to do. Okay, so you should get x is equal to, I got the square root of 1,345. I don't know what the decimal approximation for that is, but I'm just going to circle this. Okay?
Can we do that on the test?
What? That? Yeah.
Okay.
Questions on 5 or how I got 1,345, the square root of that. No? We're feeling good about the Pythagorean theorem? Yeah? Okay. So number 6 then, we have to determine if triangle PQR is a right triangle. Okay, so we're not given that it's a right triangle. So just like on the front, I want to identify which side is my longest side. Okay, the side that's the longest side is 20. So I would have 20 squared compared to 10 squared plus 10 times the square root of 3 squared. So 20 squared is 400. 10 squared is 100. Distribute your square here, so I have 10 squared is 100 times the square root of 3 squared is just 3. So we have 400 compared to 100 plus 300, which is just 400 compared to 400. So those are equal, so this would then be yes, it is a right triangle. Okay, so yes, that is a right triangle. Questions on 6? Most people did that one right as well. All right, then we're going to move on to 7. So in number 7, we just want to solve for x. Now in this one again, I'm already given this is a right triangle because it has a 90-degree angle. So we are just going to use the Pythagorean theorem. So I'm going to identify my sides. Opposite the 90-degree angle here is the hypotenuse, that's C. The other two sides are A and B. Again, those are interchangeable. It doesn't matter which is which. So here I am going to plug this into A squared plus B squared equals C squared. So we have 9 squared plus this quantity of x minus 3 squared is equal to x squared. Now before I continue, I want you to look at this quantity squared, compare it to this quantity squared. Okay, think about what is different about those two quantities squared. X minus 3 quantity squared and, stuck here, 2 times the square root of 3 quantity squared. Okay, think about what's different in those. Can anybody tell me what's different in those?
It's not multiplication.
The one on the back is not multiplication. Okay? We have x minus 3. We have a subtraction symbol there. Okay? That means I cannot distribute my square. Okay? With multiplication, you can distribute your square. So like I did up here, I distributed that square to 10 and the square root of 3. But I didn't have subtraction or addition between the two. In this one, I have a subtraction. Okay? I have subtraction. What that means is I'm taking that quantity, x minus 3, and multiplying it by itself. So I'm going to bring that over here. So that means I have x minus 3. That quantity, you have to multiply it by itself, which is x minus 3. Do you remember how I multiply those? FOIL. Okay, you do have to FOIL this. So multiplying your first terms, I have x times x, that's x squared. Your outer terms, I have x times negative 3. Your inner terms, negative 3 times x. And then your last terms, negative 3 times negative 3. Okay, so I end up with x squared minus 6x plus 9. Okay, so I want to bring that quantity back over because I just squared it. So from here, I'm going to keep going with my problem. But first, do you have questions on why I did this? No? Do you remember foiling? Yes, from last year? Yeah? Okay. So then we have 9 squared. It's 81. Plus that quantity I just foiled. So I'm going to bring that back over here. Oh, I took them away. I'm sorry. Here you go. So I have x squared minus 6x plus 9. Again, I brought that back up over here. And then that's still equal to x squared. Now what I want to do is get all of my x squareds together, all my x's together. So to do that, I'm going to subtract x squared from both sides. But what happens? They cancel here, and they cancel here. So I'm left with 81 minus 6x plus 9 is equal to what? 0. Good. Okay, so I'm going to combine 81 and 9. That's 90. And I still have that minus 6x equals 0. Okay, so combining like terms there. Now I want that 6x on one side and the 90 on the other so I can solve for x. So add 6x to both sides of your equation. So we have 90 is equal to 6x. And then from here I just want x by itself. So divide both sides by 6. To get x is equal to 15. Okay, so I have this problem on here because I didn't want you to forget how to FOIL, okay, and what it means to FOIL. Okay, so if you have that quantity squared off to the side, you can FOIL that out. If you don't need to write it off to the side, that's fine too. But then just solving for x from there. Questions on number 7? All right, then we don't have to do number 8.